Hi everyone, welcome back to my number sense series. In this video, we're going to be doing something I call evaluating quadratics. Essentially, they consist of questions like this, where they give you a quadratic and then they ask you to evaluate it at a certain point. Now, for example, in this question, you might be tempted to simply just plug in w equals 11 and you evaluate something like 11 squared plus 16 times 11 plus 64. And now, while this is possible, and I have no doubt that some of you are able to do this accurately, this is not a good way to do these questions, okay? You're going to have to do this computation, you're going to have to do this computation, and you're going to have to add all of them together, which is a really inefficient way to do these problems. Instead, in all of these problems, and number sense writes them this way, there's a critical observation that you have to make that's going to make the computation 10 times easier. And this is the observation. The formula for a plus minus b squared equals a squared plus minus, so depending on if this is a plus minus, this is a plus minus, 2ab plus b squared. I'm sure some of you already know this property, but this is going to be absolutely crucial for this video. In this video, we're going to be going from here to here. You can see that all of our questions are kind of in this form already, right? Something squared plus something times that plus 64, all of these are in this form, and we want to get it into this form because note that adding something and then squaring something is way easier than squaring something, squaring another thing, and then adding 2 times something. That's much easier to do it like this. So we want to convert it from this to this before we do any actual computation. The way we're going to do that is to look crucially at this term, 2ab, right? The coefficient specifically of 2ab, when we look at the primary variable a, the coefficient is going to be 2b, right? If the coefficient is 2b, then we can say that it's a plus b. So, for example, here, if this coefficient is 16, which is 2 times 8, then we can say this is w plus 8 squared, right? If that didn't make sense, I'll explain it again. 2ab here, if we look at the primary variable, which we'll call a, right? A is w here. Then we look at what's the coefficient. So here we have w times 16. Here we have a times 2b. So we can kind of equate 16 and 2b in our heads. And that's how we determine that b is 8. Then we can say, oh, then it goes into this form where it's a plus b, but a is w and b is 8, so it's w plus 8 squared. If that still didn't make too much sense, hopefully you will see the pattern after we do more of these. But now that we've converted it into this form, w plus 8 squared, then we can plug in w and our computation is going to be much easier. We plug in w equals 11, 11 plus 8 is 19, 19 squared is 361. And for the record, you would have gotten 361 if you plugged it in to get 121 plus 176 plus 64, but that is a much worse computation in my opinion. So let's do this problem. Once you get the hang of these problems, they are all pretty much the same. Y squared plus 8y plus 16, what is that? Well, let's kind of develop a shortcut, right? Here in order to determine b, we cut the second coefficient in half. And that is the pattern that we can use across every problem. So what is b here? b is 8 over 2. So this is going to be y plus 4, which 4 is 8 over 2, squared. So then we can plug in y is 16 plus 4, 20, 20 squared is 400. Very easy once you, learn to decompose these. Not decompose, like factor. Second question, or third question, if u equals 32, what is this big thing? And this is something you definitely do not want to evaluate. 32 squared plus 46 times 32, who's doing that? Nobody. So, of course, we should recognize it as something else. What is it? It's a u plus something squared. U plus something. But what is that something? That something is 46 over 2, 23. So it's u plus 23 squared. U is 32, so it's 32 plus 23 equals 55 squared. And we have a trick for doing this, right? In case anyone forgot, we do 5, first digit, 5 times 5 plus 1, 5 times 6, 30. And we add a 25 at the end. Answer is 3025. Fourth question, if v equals 23, what is v squared minus 2v plus 1? So this is a slightly different case because for the first time we have a negative coefficient. But don't be scared because it behaves exactly like you think it would. Because instead of saying this is v plus 1 squared, we have to take the negative coefficient into account. So it's actually just v minus 1 squared. Not so different. So then we can just plug in v as normal. 23 minus 1 is 22, and 22 squared. This is, not on the times table, but in my opinion, you should memorize it for number sense. 22 squared is 484. Last question. It's going to be pretty much the same as the rest. If w equals 27, what is w squared minus 14w plus 49? Once again, we have to determine what the quadratic is. So we're going to say this is w something squared. But what's that something? That something is going to be this coefficient, negative 14, divided by 2, which is negative 7. So it's w minus 7 squared. So then it's 27 minus 7 is 20. 20 squared is, same answer as this, 400. So this kind of problem, once you get the hang of it, it is super, super easy because there's pretty much no variation within these. The hardest part, in my opinion, is really just doing it fast, right? But there's a very nice trick for doing this. All you have to do is take a look at this coefficient divided by 2 and say it's that variable plus this squared. And then after that, all you have to do is plug this in and evaluate it. So if you haven't already been able to tell, it's very, very important that you know your squares for these. So again, like I always recommend, try to memorize your squares up to like 35 or 40 because they're going to be very crucial for this. Any squares that are too large will likely involve a trick, like the ones ending in 5, that's the most likely. And yeah, that's it for this video, and I hope you guys understood. I'll see you next time. Thank you for watching.